Sticking with the theme of separation, my next guest is Chris Kay, co-founder and president of WaHa. WaHa produces pure drinkable water from air using cutting-edge atmospheric water generation technology, metal organic frameworks, or MOFs. And when I say cutting edge, I mean it just won the Nobel Prize. The simplest way to think of a MOF is like a crystal sponge built from Legos but at molecular level. You have metal atoms, the nodes, and organic molecules called linkers that connect them. By choosing different nodes and linkers, you can build a crystalline material with a precise, repeating structure of pores. What makes this Nobel-worthy is the unprecedented control it gives us. Before MOFs, making porous materials was a bit like making a normal sponge. You get holes, but they're random in size and shape. With Prof. Yagi's method, we can design the pores to be the exact size and chemical environment that we want. And this gives MOFs a phenomenal capacity to attract and hold very specific molecules, like H2O. I was lucky enough to speak to Chris just after the Nobel Prizes were announced, so here I am, trying not to fangirl too much. Chris, huge congratulations to your co-founder, Professor Omar Yagi, on his Nobel Prize. It is a monumental achievement for reticular chemistry. For our audience of water professionals who aren't all chemists, can you break down what a metal organic framework or a MOF actually is and why it's a Nobel-worthy breakthrough?
Sure. So first thing, just as the Nobel Committee said, it's a very unique material. It's comprised of both organic and inorganic compounds. In our case, the water harvesting MOFs. So Professor Yagi invented MOFs back in the early 90s, but invented his first water harvesting MOF in the 2010s. And the Nobel Committee likened the MOFs to Hermione's handbag. That basically, it's incredible what you can put inside of it. So 1 teaspoon of the material, if fully unfolded, could cover an entire football field.
Wow.
So it's an incredible, basically, framework of materials that can each be uniquely designed to capture and separate out one molecule from a molecular stream. And in the case of what we're talking about, separating water molecules out from an airstream.
That's a fantastic explanation. So it has this phenomenal capacity to attract and hold specific molecules, and in this case, water. That's a fantastic explanation. So you have this incredible material. WaHa, the company, was founded in 2018. Can you take us back to that moment? What was the spark that turned this Nobel-winning chemistry into a company specifically dedicated now to solving water challenges?
Sure. So our initial mission statement was to provide safe drinking water to underserved communities in water-starved areas of the world. And that's a beautiful mission statement. That's why I joined. That's why all the original co-founders joined, is to deliver on that mission. And our company and our technology is uniquely positioned to deliver that. However, we also realized quite early on that mission statement, while beautiful and something we can do, is not fundable. So we have worked to find solid markets where there's solid economics to provide either pure water or dry air, because taking humidity out of the air creates dry air. So there are plenty of strong economic value propositions. And we combined Professor Yagi's MOF material with a uniquely designed, that we've patented now, desiccant regeneration engine that can regenerate the MOF very efficiently any place around the world.
Amazing. Okay, so now you've got the MOF, which is Nobel-worthy by itself. You've got now a way to regenerate it, which actually makes it applicable and usable in the real world, which then becomes bankable materials, bankable projects. Okay, amazing. So beyond harvesting water from air, how else can this sort of crystal sponge technology revolutionize the work of water professionals like this audience? What specific problems in water treatment and supply can you solve with it?
Sure. So several things. One, the material itself, focus on that. As I mentioned, it separates water from water from airstream. So the pore size is very small, and really only water molecules will fit inside of it. So volatile organic compounds, pollution won't. So I live in Colorado, our labs in California. You can run it in either of those places during fire season. You can run it in India or China, any place that's polluted, and with no additional filtration, all you get is type 2 ultra pure water. So that's one thing. So you get very pure water. The other thing is that MOFs can adsorb water at relative humidities down to 7%. So in very arid conditions, so we have machines running in Riyadh in the UAE and in Sweden, so where it's cold, so it can supply that. The other thing is that we're not competing against traditional sources of water. We want to supplement them because the water we provide is very pure potable water, or can be made potable by adding minerals back in. So it's a supplement to what professionals do. So no PFAS, no microplastics, heavy metals, nothing, just pure water.
So if I've understood this correctly, then it's like a precision filter that just pulls the water molecules away from everything else. You don't have to find a water source and then try and remove things like PFAS or toxic metals or specific industrial pollutants out of the water. When you get it, it's already pure.
That's it. So, right. In fact, again, we like to think of it as, not even think of it, we call it a nano-separator, not a filter, because it separates out water molecules from everything else in an airstream. And then our engine makes a very efficient way to regenerate that, so we can get the water then out of the material and condensed into something to either be used for drinking or for agriculture or pharmaceuticals, or obviously many other things.
Okay, it's absolutely transformative. I cannot overstate how disruptive this technology is going to be. But for the sake of the audience, again, if you look ahead 5 to 10 years, Chris, what's your vision for the role that WaHa, your company, and that MOF technology will play in creating a more water secure and energy efficient future?
Right. Well, one of the things is that if you look at us like a server farm or a disk farm, also like cell phones, we're a distributed solution. We're not a centralized solution like what water utilities professionals have been dealing with so far. So you can put our machines out and scale them anywhere, and because our machines are small and be used to fail over one to the other, we can provide, and we already have 5 nines, working towards 6 nines of reliability, just through a bunch of small machines working together. So very scalable, low cost, high reliability, pure water that you can. So instead of dealing with just one central facility, then you can deal with many others. The other thing is our business model. We want to sell water, not machines. So that's what water utilities do. And ultimately, we think we can provide the most sustainable water solution by helping water utilities and consumers at large take the bottle out of the bottled water market. Because instead of sourcing water or providing bottled water where it's sourced, we provide water where it's consumed. So you eliminate all the packaging, you eliminate all the distribution, you can generate it anywhere in the world.
Fantastic. And it's much more economically viable, because we all know with water, we have the opposite of economies of scale. The more you want, traditionally, the further you have to go to get it. Whereas in this case, right, you're generating water right where it is. So it could be anywhere. That's amazing. Chris, this has been an incredibly insightful and compelling discussion for the use of MOFs for decentralized, for ultra pure, for water, for almost any situation, in any situation. Thank you so much for sharing the story and your vision with the audience. For those eager to learn more, where can they find information about MOF and about WaHa and what you do?
Well, about MOF, you could check out Professor Yagi's website at University of California at Berkeley. can tell you what he's researching on MOF. But in terms of how we're using water harvesting MOFs and integrating it with machines to deliver safe drinking water anywhere around the world, check out our website at www.wahainc.com.
Thank you, Chris, for sharing your story of the spark of academic research and its journey into application in the real world.